Okay, today is slope. Slope of a line. Now, we've been graphing these lines. You guys know how to make these lines. Well, now we're going to talk about slope and how it works. Slope is either positive or negative. And the first thing to figure this out, the first part of this is actually very easy. To determine whether or not slope is positive or negative, what you can do is you can read it like a book, from left to right. If you're looking from left to right, if it goes up from left to right, slope is positive. So this actual slope is positive. So from left to right, it goes up. From left to right, if it goes down like that, if you look from here to here, as it goes down, it's going to be negative. Okay? What? Not from left to right, it's not. From left to right, as you think of a book. When you read something, you read left to right. Left to right, if you're going up, it's positive. Left to right, if it's going down, it's negative. Okay? The other thing that in order to find slope, you have a couple steps. Step number one, what I want you to do is determine whether it's positive or negative. Okay? And you determine whether it's positive or negative by reading it like a book, left to right. If it goes up, left to right, it's positive. If it goes down, it's negative. Step number two, I want you to find 2 points where the line crosses an intersection. So on this, it crosses an intersection right here. This one, it doesn't quite cross. This one, it definitely doesn't cross. This one, it doesn't cross. But this one, it does, for sure. Okay? You see what I mean by cross? Meaning that line hits exactly where these blue lines intersect. Okay? So I mark the 2 points where they intersect. So that's step number 2. Mark the points where they intersect. Now, slope is determined by rise over run, meaning how far up or how far down it goes, over how far over it goes. Rise over run. So to get from this point to this point, how far up do we go? 1, 2, 3, 4. 4. 1, 2, 3, 4. 4. And how far over do we have to go? 3. 1, 2, 3. And then reduce if we can. But this one we're not going to reduce. We can't really reduce this unless we make it a mixed number, but it's a ratio. And because it's a ratio, we're going to leave it the way that it is. Okay? Does that make sense? No. First of all, we're going to determine the slope. Is it positive or negative? Okay. So I'm not going to put any symbol there. I'm not going to put a negative or it's positive. So we're going to leave it the way that it is. Slope equals x. The next thing that we need to do is we need to find 2 spots where it crosses an intersection. Yes. 0, 4? You mean up there?
No.
Oh. 4, 0. So it crosses an intersection right there. True. Tell me out. -4, 0, you mean over here? Oh, okay. 0, -4. Definitely crosses there. Okay. You could have said any of these. You could have said that it crosses at 1, -3. You could have said it crosses at 2, -2. You could have said it crosses at 3, -1. You could have said any one of those, and this would work, as long as you have 2 points. Yes. Nope. The slope will not be any different. And I'll show you that. I'll prove that. Now, the next step, step number 2 is find 2 intersections. Step number 3, how far up or down do we have to go to get to the next dot? How far up do we have to go? 4. 1, 2, 3, 4. So it's going to be 4 over. How far over do we have to go? 4. Step number 4 was find how far over is. Step number 5, reduce if we can. What? 1. What? You're not going to have curved lines. Okay, now to answer your question, what if we chose this spot? What if we chose -2? What if we chose that? And we didn't choose this one? Well, look. How far up do we have to go? How far over do we have to go? It's the same. As long as we find 2 points where the intersection is, that's the best. That will give you your, that's going to give you your slope. First of all, positive or negative? It's negative because when you read it like a book, left to right, it goes down. So my slope is going to be negative. So I'm going to put a negative symbol just to begin with. It's negative. Now, it gives us 2 points that it intersects. It already gives us 2 dots there. So how far over do we have to go to get to the next dot? No, actually, I'm sorry. It's rise over run. So we have to figure, the top one is going to be, how far up or down do we have to go? I messed that up. So how far up or down? 2. We got to go 1, 2 to get down. So from here to there is 1, 2. So it's 2. How far over do we have to go? 1, 2, 3. That's our slope. It's -2 over 3. Because my slope is negative because it's like this. Okay? The top number is just how far up or down you're going. It doesn't matter. Okay? The top number is how far up or down. The bottom number is how far over. Negative is determined by reading it by the book. Okay? Reading my book, left to right. So follow the steps that I gave you. First of all, read it like a book. Positive or negative? Cesar. Positive. Okay, so I'm not going to put any symbol. Pick 2 points where it crosses an intersection. It's not a trick question. Any spot where it crosses an intersection. Leah. Negative what? What? -1, -1. Okay, good, right there. Give me another spot where it crosses an intersection. 2, -1. 1, 2, -1. Good. Okay, crosses the intersection there. Now, slope is determined by the top number is how far up you go by how far over you go. Okay? So how far up did we go or down to get from this spot to that spot? 0. How far over did we go to get to that spot? 1, 1, 2, 3. Last step, reduce if we can. What's 0 divided by 3? My slope is 0. Because it's a flat line. My slope is 0. Not if you're going sledding, you don't like that slope. Unless someone's pulling you. Again, positive or negative? Negative, because left to right it's going down. So my slope equals negative. Okay, let's find 2 spots where it intersects. 2 intersections. Jeremiah? -2, 4. Okay, there's one. That's a bad spot. Okay, so there's one. Give me another one. 0, -4. Okay, it definitely crosses there too. Okay. How far up or down do we have to go to get from that spot to that spot? 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. How far over do we have to go to get to that spot? 2. 1, 2. Reduce if we can. Yep. Not 4 though. See this? -4. Don't forget about that negative. But yes, 4, if you do the division, that's correct. But don't forget about the negative. -4. That's my slope, -4. Now, you're also going to have problems that look like this. Basically, we're going to be working slope backwards. It says use the slope -2, 1, and the point 1, -1 to graph the line. So here's what I need you to understand. First of all, we have a point. It's right there. That is one of the points on my line. That is one. Now, the next thing I want you to think about is my line going to go like this, or is my line going to go like that? Which one? This one or this one? Left or right? Left one. You're saying my thing's going to be like that. Why? Because it's negative. And left to right, it's going down. And this negative tells us that it has to do that. So we know, now we're thinking ahead of time, that we know that our line should look something going like this way, okay? And if it's not, we did something wrong. So we're going to use that point. Now, it's rise over run. The 2 on the top tells us how far up or down we have to go. Okay? So from here, do you want to go up or down? Sure. Okay. Honestly, it doesn't really matter. It really doesn't make a difference. We could go up or down. The second one, it tells us what way the thing is going to be turned. Okay, so you want to go down. So now we're here. Now we go run. We got to go over. Now if we go this way 1, and our dot's right there, does our line look like it's supposed to? No. So we got to go this way over 1. Now, there's my line. I know because I want my line to slope negative. If I put it on this side, my line slopes positive, and I didn't do it right. So the hardest part of this is figuring out, first of all, visualize what way is your line going to be. Is it going to be negative, or your answer going to be negative, or is it going to be positive? All right. Now, is my line going to be like this, or is it going to be like this? Left or right? Right. So this is the one. It's going to have to look like that. And then I got my dot. 1, 2. So the first one tells me how far to go up or down. Doesn't matter up or down, which way do you want to go? How many? 1. So now I'm here. I'm at this spot. I'm at that intersection right there. 2 tells me how far over to go. Do I want to go left or do I want to go right? Jeremiah, I want to go to the right too. 1, 2. There we go. It's kind of a bad line. However, please, when you guys do it, use a straight edge and make sure your lines go there. I can't do it on the smartboard. It won't work. Okay? Make sure it goes through the dots. Connect the dots. Except like Charlie, you go all the way through the dots and keep going. Okay? I'm gonna skip this. I think you guys got that part. You're also going to have questions that look like this. Let's say, tell whether a graph shows a constant or variable rate of change. Let's think about our words, constant and variable. What does constant mean? Stays the same. Variable, what does variable mean? It can change. So what line do you think shows a constant, and what line do you think shows variable? Marissa? A shows what? A shows variable because that's changing. And then obviously B must be constant because so it doesn't change, it stays the same. The graph shows the distance a monarch butterfly travels over time. Tell whether the graph shows a constant or variable rate of change. Then find out how fast the butterfly is traveling. What? First of all, is it constant or variable? It's constant. Well, then find out how fast. Don't make it more complicated than it is. 20 miles per hour. 1 hour, he goes 20 miles. 20 miles an hour. Like I said, don't make it harder than it is. Okay? No. For your homework, you have a worksheet. I'm going to hand out the worksheet. On this worksheet, it gives you a graph, or it gives you a table, and the table shows a bunch of numbers, and it asks if this table represents a variable or a constant rate of change. My suggestion to you is to look at the graph paper that I'm going to give you in addition. Use that graph paper to help you determine whether or not that table creates a straight line or a curved line. Okay?